Good morning, students. Today we will discuss Chapter 2 Physical Features of India, that is Geography, Grade 9th. Today we have to discuss page 7. Okay, so NCERT book, page 7. Now, students, India is vast country with different landforms. So, India is a vast country with different kinds of landforms. In plain area, there are vast stretches of plain land. In hilly areas, we have rough and uneven terrain, that is the land with mountains and valley. And in India we have all major physical features of the earth, that is mountains, plains, deserts, plateaus and islands. So different variations are found in our country. We find different rocks, some are hard like marble and some are very soft like soft stone, which is used in making talcum powder. So on one hand we have hard rocks and on the other hand we also have very soft rocks from which we extract our talcum powder. So the color of soil is also varies from place to place. If you have seen the alluvial soil, red soil, then we have black soil, then arid soil, mountainous soil. So all these soils, they vary from region to region also. But now the question arises, why these variations are there? So most of these variations are caused due to the differences in the rock formation. Number of processes such as weathering, erosion, deposition have created and modified the relief to its present form. Weathering means the breaking down of rocks and minerals on Earth's surface due to the exposure to excess heat, rainfall and cold temperature. And erosion, the process in which the earthen material are worn away and transported by natural forces such as wind or water. And deposition, the gradual forming of layers of a substance. Now, to explain the formation of the physical features, we have to understand the theory of plate tectonics. In order to understand how these physical features were formed, we have to understand the theory of plate tectonics. Now, according to the theory of plate tectonics, our Earth is divided into different layers, that is crust, then mantle, and then core. Inside, magma is there in the mantle, and Earth crust is divided into 7 major and minor plates. So, our Earth is divided into different layers, that is crust, mantle, and core. And inside the mantle, magma is there, and the Earth crust is now divided into 7 major and minor plates. So the earth crust is divided into different tracts known as plates, and these plates are continuously moving or floating on magma, and magma is in semi-molten state. Now this leads to the folding, faulting and volcanic activity. Now students understand magma is in semi-molten form, so earth crust is not a single plate but divided into 7 major and minor plates. So these plates keep on moving very slowly and keep on floating over the magma. So the plates keep on floating and moving on this semi-liquid magma. Now how with this phenomenon structures are formed, this we have to see. So due to the movement of plates, various changes occur, and there are 3 main plate movements. So I told you that there are plates, the earth crust is divided into the plates. This plates is moving on the molten magma, floating on the molten magma, and then the movements is there in the plate, different movements are there in the plate. So let's see the 3 main plate movements. First is convergent plate, then the divergent plate, and then the transform boundary. So the convergent plate means when two plates come towards each other. So this is called the convergent plate. When two plates come towards each other and collision is happened, so this is also known as folding. So this leads to the formation of mountain. So due to the convergence or converging of two plates, it leads to folding. When two plates come together, collide, and mountains are formed, and this process is known as folding. So folding is a process that causes a bend in a rock. Next moment is divergent plate, the convection currents. So please understand, students, inside the mantle, inside our earth crust, so many convection currents also originate because of the hot molten magma, because of which all this movement happened due to the convection currents which come from the interior of our earth. So the convection currents which originate from the bottom due to the heat from magma, so this convection currents split the earth crust apart. So the two plates, they move away from each other. So it will leads to the formation of rift valley. Then rivers can cross from this rift valley, and this process is known as faulting. So faulting, when a crack in earth crust appears resulting from the displacement of one side with respect to others. So in this, the two plates will move away from each other, divergent. So they will diverge from each other. Then is transform boundary. So where motion is predominantly horizontal and plates move horizontally. So plates move horizontal, they can slide horizontally, and places where plates slide past each other are called transform boundary. And due to this plates movement, our this earthquakes and volcanoes happen. So due to these place movements, plates collide, they crumble, and they slide under each other. So these movements had resulted in the formation and evolution of the present landform features of India. Now on page 8 we have to see the formation of Indian landmass. So till now I have told you about the earth layers, different layers of our earth, that is crust, then mantle, then core. And then I have told you that our earth crust is divided into 7 major and minor plates. And then I had told you about the plates movement, that various kinds of movements happen within the plates. I have told you convergent movements, divergent, and transform boundary, due to which these landforms are made or formed. So now let's see how our Indian landmass was formed. So for this we have to understand the story of Pangaea and Panthalassa. Now lithospheric slabs or the plates were floating on molten magma according to the theory of plate tectonics. So this I told you that our earth crust is divided into 7 plates, 7 major and minor plates, and these plates are floating on the molten magma. So plates move in different directions. This also I have told you that plates float on molten magma. Convection currents originate within the interior and causes the plates to move, sometimes towards and sometimes away from each other. Now, how the Indian land mass was made. To understand this, we have to understand story of Pangaea and Panthalassa. Now, million of years ago, we were having only one land mass, that is Pangaea. Oceanic part was Panthalassa Ocean. So this Pangaea landmass was also floating on magma, and continuous convection currents originate in the molten magma. So these convection currents subside and cracks develop in the land plates. Now, the southern part of this supercontinent Pangaea was Gondwana land. So please understand this, Gondwana land was the peninsular part. And northern part of this supercontinent was Angara land, and Angara land was also called Laurasia, and within Laurasia we have Eurasian plate also. So the Gondwana land included India, Australia, South Africa, South America, Antarctica. So all these were considered to be one single landmass. So it means India was part of Gondwana land, and Gondwana land was the southern part of Pangaea. Please understand this thing. After this, now we have to see why this single landmass of Gondwana land can't stay together. Now you know the convectional currents split the crust into a number of pieces. So the plates started moving. So after the split, major continents and plates were constructed, and after the split, plates started drifting in different direction, and the Indo-Australian plate drifted towards the north. Now the northward drift of Indo-Australian plate resulted into the collision with the Eurasian plate, thus forming the Indian landmass, and further many other features were also continued to develop after this. Now we have to see the formation of Himalayas and northern plains. Now formation of both physical features of our Himalayas and northern plains are interrelated and connected with drifting. That is, they were the plates when they carried slowly and they move and they float, specifically the Indo-Australian plate. When drifting starts, then the collision happens between the Indo-Australian plate and Eurasian plate. So I told you that Gondwana land was the part of the Pangaea, the southern part of the supercontinent Pangaea. Then the Indo-Australian plate, it split and then start moving towards the Eurasian plate and collision happened. Now in between the Indo-Australian plate and the Eurasian plate was the Tethys Sea. So Tethys Sea lie between the Indo-Australian plate and the Eurasian plate. Now the Indo-Australian plate started moving towards the north and collision happened with the Eurasian plate, because Eurasian plate was more large and more stable plate, and in between them was the Tethys Sea. So Tethys Sea started shrinking and all the sediments in the sea got uplifted to form the Himalayan ranges. So I told you Eurasian plate was more stable. That's why when Indo-Australian plate got slipped under the Eurasian plate, then in between was the Tethys Sea, so it got uplifted. So it uplifted. So after that, due to this collision, the sedimentary rocks which were accumulated in the geosyncline known as Tethys were folded to form Himalayas. Geosyncline is nothing but a large scale depression in the earth crust containing very large and very thick deposits. So here geosyncline is referred to as Tethys. So this was how our Himalayas were formed. Now let's see the northern place. Now due to the folding process, the Himalayas were formed. You have seen collision, formation of the large basin at the foothills. So due to all this collision, Himalayas were formed, and due to collision, the large basin, that is the depression, was also created at the foothills of Himalayas. Now due to the collision of Indo-Australian and Eurasian plate, Himalayas were formed. This we have seen. After this, when mountains were formed, then on the foothills of the mountain, depression is created. So the depression is created at the base. In due course of time, this depression got filled by the sediments which were brought by the rivers from the Himalayas. And the area between Himalayas in the north and the Peninsular Plateau in the south got filled with the alluvial deposits. So this is how our northern plains were formed. And the Peninsular Plateau, the formation of the Peninsular Plateau was mainly due to the volcanic activities which occurred during the plate movement. Deccan Trap is formed due to the volcanic eruptions and not any sort of collision. And in Earth we have seen the volcanic hotspots. So due to the convectional currents, volcanic eruption occur on these hotspots also. So this molten lava comes, spreads and settles down and solidifies as land, and Peninsular Plateau constitute one of the ancient land masses on the Earth's surface. It was supposed to be one of the most stable land blocks, because these were present even when the Indo-Australian and the Eurasian plates collided. Himalayas and northern plains were formed after the collision, but this Deccan Plateau and the peninsular part were present earlier also before the collision. So this Peninsular Plateau was stable land block, because whatever collision happened, the effect was visible on the margins. It will be the Himalayas and the northern plains, they got affected. The peninsular part was little behind and located inside of the the Gondwana landmass. So whenever plates will collide at that time, Himalayan part will be more affected. But the peninsular part is more stable as it is in the interior of the land. So the Himalayas, they will represent most youthful topography because of the latest formation of Himalayas in the northern plains, and Peninsular Plateau will reflect the old topography.